Good morning, ladies and gentlemen. We are pleased to present lactic acid as the subject of our design project. Today's presentation will cover the basis of lactic acid, as well as its location, next is production rate, and then we will talk about process simulation, economic evaluation, safety, and finally is conclusion. So let's get started with lactic acid. Lactic acid has two functional groups, acid group and hydroxyl group. And lactic acid is one of the most important organic acids on the market due to its wide range of applications. For example, in the cosmetic, food, chemical, pharmaceutical, and chemical feedstock.
As you know, there are two different ways to produce lactic acid. Let's consider the comparison of 5 sustainability metrics for biotechnological and chemical process. The first one is math efficiency, that measures the efficiency with all process input and up the design product. The second is E factor, that represents environmental impact. The third is energy efficiency. The fourth is land use. And finally, we consider cost. This table shows that math efficiency of bio-based less than chemical, and E factor is more, but the waste that produced in bio-based can be sold. Energy efficiency is high and the total cost is less than chemical. After the comparison, we decided to produce lactic acid by biotechnological process.
And we should consider to produce lactic acid because it is inexpensive, produce a high yield, and is available all year.
Like to locate at Pak Chong District, Nakhon Ratchasima. Before we make the decisions, we need to consider factors include with raw material, market, labor, transportation, power and water, land, climate, and facility. For the raw material, it's the significant factor. Corn stover was go a lot at เพชรบูรณ์นครราชสีมา น่าน ตาก and เลย but we chose นครราชสีมา because it is not far from the Bangkok and it is a big city, it's not far from the port. After that, we focus on the district. There are two districts in Nakhon Ratchasima that have a lot of corn areด่านขุนทด district and Pak Chong district. We chose Pak Chong district because they have the former chemical products. Why the food grade was chosen is because of the demand of the customer, and moreover, the food grade LA has a lot of applications and it has a high import rate.
For the production rate and customer, the global lactic acid market size was valued at $2.7 billion in 2020 and is expected to expand at a compound annual growth rate of 8% from 2021 to 2028. Thailand has a lead Caribbean company to export lactic acid and PLA or polylactic acid. In 2018, the Caribbean company's production of lactic acid was 140,000 tons per year, and the production capacity was increased by 125,000 tons per year in 2020. So we should the production rate is 106,000 tons per year and sell in price $1.2 per kilogram, which is the production rate close to the best of the major Thai lactic acid exporter and covers the increasing demand of the world market every year and can still get a profit and pay back within 4 years. On the customer side, there are large and small international companies in Asia, Europe, Americas, and Africa that need to import large quantity of lactic acids, such as MK Traders, Pioneer Chemicals, SSD Industries, and Perigo.
In this section, I will describe lactic acid production process before adding heat exchanger network. It divided into three main sections: fermentation, recovery of lactic acid, and purification. First, corn stopper is initially crushed in a pretreatment process using a ball mill and fed in steam 1. The feed steam 2 is water. Both steams are mixed and heated to 50 degrees Celsius at atmospheric pressure and enter to the reactor R100 with the enzyme Lactic causing enzymatic hydrolysis reaction. Cellulose and hemicellulose in corn stopper are reacted with water and converted to glucose and cellulose. The remaining corn stopper residue is separated in steam 6. Then glucose and cellulose are sent to fermentation process in reactor R101 with lactobacillus at atmospheric pressure of 45 degrees Celsius and calcium hydroxide is added to adjust the pH. In this reactor, glucose and cellulose convert to lactic acid. After that, residual waste are separated in steam 12. Next is the lactic acid recovery part. Since calcium hydroxide reacts with lactic acid to form calcium lactate and water, lactic acid has to be recovered by using sulfuric acid to react with calcium lactate back to lactic acid, and a byproduct is gypsum, which is separated in steam 18. This reaction takes place at atmospheric pressure of 95 degrees Celsius in reactor 102. Now we can produce lactic acid, but the purity is not yet as required, so the last part is the purification part. Steam 19 is taken into a distillation tower D100 to separate sulfuric acid from lactic acid. After that, water is separated from lactic acid in pre-concentrated batch F100, but there is still a large amount of water which causes the lactic acid to not reach the desired purity because lactic acid has a strong affinity with water. Therefore, the esterification process will use ethanol is fed into steam 25 to react with lactic acid in the reactor R104 and form into ethyl lactate and water by using embedded catalyst. Ethyl lactate is easier separated from water than lactic acid. Therefore, in the distillation tower D101, water can separate from ethyl lactate. When a large amount of water can be separated, we convert ethyl lactate back to lactic acid by hydrolysis. The remaining water reacts with ethyl lactate back to lactic acid and ethanol by using acid resin catalyst. Then steam 31 is sent to the distillation tower D102 to separate lactic acid and ethanol. Ethanol in steam 32 is recycled back to esterification section, and lactic acid in steam 33 obtains desired purity and is cooled to store at the room temp. Finally, production rate is 106,000 tons per year.
Consider heat exchanger network to design MER network. First, we calculate pinch temperature. These are hot and cold pinch. The value of it is 36.8 and 26.8 degrees Celsius respectively. Just show the MER network we design. First, consider above pinch region. H3 stream start 131.8 and it transfer heat to C1 and the temperature is go to hot pinch temperature. Next, H1 start 104 degrees Celsius. It transfer heat to C1 and temperature is go to 70 degrees Celsius. H2 start 105 degrees Celsius and it transfer heat to C1 and the temperature is go down to 100 degrees Celsius. C1 is a cold stream in the above pinch region. The temperature start at cold pinch temperature. It receives heat from H1, H2, and H3 stream, and the temperature is up to 39.8, and this temperature is enough. The goal temperature is 50, so we use hot utility to heat it up. C3 start at 45 degrees Celsius. We also use hot utility to heat it up to 95 degrees Celsius. And the last cold stream is C4. We use hot utility, and its final temperature is 95. If below pinch region was concerned, we can observe that H3 stream at hot pin temperature was split to two streams is equivalent for lead, and transfer heat to C2 and C4 stream. And we use the cold utility to cool it down to 25 degrees Celsius. C2 and C4 start at 25 degrees Celsius. Then it receives heat from H3, and the temperature is increased to cold pinch temperature, or rather 26.8 degrees Celsius.
Process improvement was made by adding the heat exchanger as calculated. It consists of 2 shell and tube heat exchanger and 3 double pile heat exchanger. According to the Aspen analyzer, the process including the heat exchanger can save operating cost and utility cost about $940,000 per year.
Equipment, and we follow by the book Conceptual Design of Chemical Processes and Plant Design and Economic for Chemical Engineering, and we got our equipment is 4.59 multiplied by 10 to the power 6, and for annual cost of raw material and chemical substance, if we know how many we want in per year and we know the price, we can find the total price, and the total price of our process is 6.3 multiplied by 10 to the power 7. And then we know the purchase cost of equipment already. We can select the percentage of FCI, and then we will know the direct cost and the indirect cost, and then we can find the fixed capital cost, investment, and then we will know the total capital investment, and our total capital investment is 1.05 multiplied by 10 to the power 8. And then we will know the fixed cost already and the working capital cost already. We can find the return investment, and for our project we can turn the money back in 4 years.
For the safety, chemical running of lactic acid. Lactic acid is a crystallized or colorless to yellow liquid, slightly acrid odor, corrosive, causes a serious burns to eyes, skin, respiratory tract, also causes coughing, dental corrosion, eczema, conjunctivitis, cornea, and edema. For the NFPA of lactic acids, our for health hazards of lactic acid is 3 is a serious toxic, and for the fire hazards of lactic acid is 0, it will not burn, and for the reactivity of our lactic acid is 0, is a health hazards of sulfuric acid is 3 is a serious toxic, and for the fire hazards of sulfuric acid is 0, it will not burn, and for the reactivity of the sulfuric acid is 2, is mean violent chemical change. Our product is a lactic acid with a purity 88% in the food grade. For the production rate is 106,000 tons per year, and for the sale price is $1.2 per kilogram. For the total capital cost is 105 million $, and for the total utilities cost is 22 $1,008,000 per year, and for the total income is $117 million per year, and it will return the internal cost within 4 years. For the recommendation, first one is the safety in the factory has not been taken into the account in terms of machinery and safety equipment in the factories at the various points. And next one is the cost of safety equipment is not included in the economic aspect. Therefore, the safety cost should be calculated for more result accuracy. And next one, the plan should be required to design its construction and layout in order to more accurately reflect the cost of capital in terms of construction costs. And last one is plants can develop processes to produce more pure products for further use in the production of polylactic acid. Thank you for your attention.